and look at 2.2. Just about time to get started here. So we just did 2.1, and when we did 2.1, we were learning how to move things across with addition and subtraction, right? Okay. Now in 2.2, we're going to be learning how to get rid of a number in front of the variable. And this is very, very easy to do, very simple. Just like 2.1, there's not a lot of steps on these. But we're going to learn how to just solve them when there's a number in front. So we'll just pick a couple of these from our textbook to look at. Let's look at on page 116. Let's look at question 28. And again, if you don't have your textbook with you, that's fine. You can write up the problems on the whiteboard here. Okay, now, first off, there's no addition, no subtraction. So we've got negative 9x equals 36. So what we need to do is we need to figure out how we can get the x by itself. Now we work in terms of opposites. So how does that negative 9 relate to the x? Well, that negative 9 relates to the x by multiplication. So what's the opposite of multiplication? Division. Okay, so I need to get rid of that negative 9 in front, and it's multiplication. So what's going to undo multiplication? Division. So I'm going to divide both sides by negative 9. And negative divided by negative makes it positive, and 9 divided by 9 goes away and makes it an x. Now what about 36 over 9? Well, we might be able to reduce that down a bit, because 36 and 9 both have a 3 in them. So let's see how far we can go with this. Maybe even further, because if we take 36 and we divide that by 9, what do we get? We get 4. And positive divided by negative makes it a what? Negative. So what would my complete and finished answer be? Negative 4. So in that case, my answer is negative 4. Right? We didn't have to move things around. We just used division. What about if there's no number in front? Just a negative. Question 36. Negative t equals 14. Okay? We don't want a negative t, we want it to be positive. It has to be the variable by itself on the left with no number or negative symbol with it. So we need to get rid of that negative. Well, how do we get rid of it? We divide by a negative 1. That's going to switch my signs. And negative divided by a negative, that makes it a positive t. And positive 14 divided by a negative 1, that makes it a negative 14. So there's not a lot to do with these. How do we handle fractions? Well, we can handle fractions a couple of different ways. I'm going to show you how to clear out your fractions. So let's start with, how about an easy one? How about question 54? So whenever we have fractions, from now on we can clear them out. You can work with them if you want, like we did earlier, or you can clear them out. Now I want to get rid of that 8 down below. And so I have an 8 down below. So I can get rid of that 8 down below by multiplying everything by an 8. Right? So that's going to clear out my fraction. Let me find a better marker. So I'm going to multiply everything by an 8. And that's going to clear out my fraction. So I put it up front. And then I distribute through. Now, the 8's cancel because 8 divided by 8 is a 1. Okay, 8 divided by 8 is a 1. So that goes away, and that makes it a single r. Next, we have 8 times a negative 3. And 8 times a negative 3, well, that would make it a negative 24. So there's your answer, with r equaling a negative 24. If you have several fractions, we have to get rid of them together all at once. So let's look at 59. And this is going to use the least common denominators here. So question 59. We have a minus 7/9 x equals 3/5. Now we need a least common denominator. And the least common denominator of 9 and 5 would be what? 9 and 5, okay, would be a 45, wouldn't it? Because 45 is going to go into both of them. Now, what we're going to do is we're going to multiply everything by a 45. So let's go ahead and put our 45 out in front. And we're going to go through this one very slowly, and then we're going to talk about several others that are just like this also. So we're going to have to multiply everything by a 45. And we're going to do several of these. So we're going to really take our time here. And this is how we can clear out our fractions. When you have an equal sign, you can clear the fractions by using the common denominator. When we clear the fractions, what we do is we divide by the number down below, multiply by the number on the top. So 45 divided by 9. What is 45 divided by 9? That's 5, right? 5 times the negative 7 on the top. 5 times that negative 7, that leaves you with a what? Yep, negative 35, right? And then we bring our x with it. Hey, it's easy. We all make mistakes once in a while, so not a big deal. So we now repeat the process again. Divide, multiply. Divide by the number down below, multiply by the number on the top. So on the next one, 45 divided by 5, that's a 9. 9 times 3 makes it a 27. Now is everyone okay with how I cleared that out? So now all the fractions are gone. Okay, so they're all gone. Now what do we need to do? We need to get that x by itself. How does that 35 relate to the x? By multiplication. So we need to get rid of it. It's a negative 35. So we're going to have to divide by a negative 35. That'll get rid of that piece. So negatives cancel, the 35s cancel. So that leaves you with an x on the left. On the right, all we're going to do is bring that negative up to the top. And that's going to be a minus 27 over 35. So that's going to be my answer on that one. And that's going to be a minus 27, I can say it right there, over 35. And we're going to do several of these where we clear up the fractions. 65 is another one. You can work with the fractions or you can clear them out. Either way. If you want to combine them together, you can. Generally, those students just want to get rid of them. But if you want to, you can combine them together just like we did earlier. But I think we'll go ahead and clear them out. Okay, so least common denominator of 5 and 10 would be what? Would be 10, right? Because 10 goes into both. So that means we've got to multiply everything now by 10. So I'm going to put my 10 out in front. I'm going to draw my arrows. What do? Divide by the number down below, multiply by the number on the top. So 10 divided by 5. 10 divided by 5 is 2. 2 times 2 makes it a 4x. 10 divided by 10 is a 1. 1 times a negative 3, that makes it a negative 3, and we'll bring down our x. Now, do not forget the right-hand side. 10 times 2 makes it a 20. Now we can finish it. Fractions are gone. 4x minus 3x, those can go together. And that makes it now a single x, and x now equals what? 20. So if you want to add the fractions together, you can do it that way. If you'd rather just get rid of them, which is what most students want to do, you can get rid of them by multiplying. Let's try one that has more pieces, 74. And 74 is 2/5 x plus 1/10 x minus 1 over 20 x equals 18. Okay, so I want to go ahead and get rid of all of these fractions. And I've got a 5, a 10, and a 20. Well, 20 is going to go into all of them, isn't it? Right? It's 20 going to 5, 10, and itself. So we're now going to multiply everything by a 20. Divide, multiply. 20 divided by 5. 4. 4 times 2 makes it 8x. 20 divided by 10. 2. 2 times 1 makes it a 2. Bring down your x. 20 divided by 20 is a 1. 1 times a negative 1, that makes it a negative x. Do not forget the other side. We've got 18 times 20. I think that should be 360. Let me double check and make sure. If in doubt, always use a calculator. Yep, it'll be 360. I have to go through each piece, all of them. Now what can we do? Now we can just simply combine. We've got an 8. 2 makes it 10. Minus 1 makes it 9x, and that equals 360. Divide that by 9 on both sides. And I believe that should be 40. But let me double check just to make sure I don't make a mistake. Yep, and it is 40. So you're now learning how to clear the fractions, and this is just a different technique that you can use here. That now finishes up 2, 2. Okay, there's not much in 2, 2. I think we've got enough time to look at 2, 3, and 4 because they're very short sections, and all it's doing is combining what we did in 2, 1, and 2, 2. So nothing new in these. We're just putting everything together. When we go to 2, 3, and 4, we need to talk about the different types of equations. And there's 3 basic types. There's the conditional equation. And for the conditional equation, we solve it and we get an answer. All of the ones that we have done before have been conditional. Okay, so everything we've done before has been conditional. So let's just solve this one. Okay, this is going to be an example of a conditional equation. And it's going to require us to use all the techniques that we've learned so far. So what do we do first? Well, first things first, always parentheses. So let's solve this out. Let's use our parentheses first and distribute that 3 through. And then we'll see what we're working with. So go ahead and distribute that 3 through. And that's going to be 3x minus 15. And that equals 5x plus 1. Now what do we need to do? Well, we need to make sure that our variable is on the left. So I'm going to move that 5x over to join that 3x with subtraction. I always like to move the variables first. You can do it either order, but I always like to do it the same way every time. So I'm going to move that variable over first. 3 minus 5, that makes it a minus 2x minus 15 equals 1. Next step is add that 15 to each side. That's going to leave you now with a minus 2x equals 1 plus 15, that's a 16. And the last step, you divide by a negative 2. And that makes your answer now come out to be, when we divide, those cancel. 16 divided by a negative 2, well, that comes out to be a negative 8. That's an example of a conditional equation. And everything we've done so far has been conditional. We solve it, we get an answer. Okay? Very simple. There are two other types that we need to look at. There's the identity, and there's the contradiction. So the identity is when the sides are the same. So when we talk about an identity, the sides are the same. Now, they may not look the same at the very beginning, but at the end they will be. So this is going to be another example. And this is going to be an example of an identity. And on the identity, when we work it all out, the sides are going to be exactly the same. Now, it doesn't look like they're the same right now, but once we start distributing and working with it, you'll see that they are. So we're going to go ahead now and distribute that 5 through. And so distributing that 5 through, well, that would give you now a 5x and a minus 50. So the left side is done. When we look at the right side, those can go together because they're the same. So a 3x and a 2x, those are like terms. So those can go together, makes it a 5x. These are the same. If the sides are the same, then this is called an identity. And for the identity, your solution is going to be all real numbers. So this is an identity, and it will be all real numbers. And what that means is any number that I plug in is going to be the same on both sides. So there's an infinite number of solutions. It's called an identity. I remember it by identical twins. Identical twins are the same, so the sides are the same. If the sides are the same, once you work it all out, it is an identity. You don't have to move the x's over or anything else. Once you get to the spot to where you can see these are identical, this is an identity. And it's an identity, and your solution set is always for all identities going to be all real numbers. The last type of equation is a contradiction. Now, a contradiction is a false statement. So the contradiction is just going to be a false statement. And let's just take a moment and think about a courtroom. And if they accuse you of giving contradictory testimony, what does that mean? That means you lied, you gave a false statement, right? Doesn't make sense. Maybe the person wasn't there, but you said that they were. You gave contradictory testimony, a false statement. In mathematics, it's done the same way. You end up with something that doesn't work. And for a contradiction, the variables are going to go away, but you're going to be left with something that doesn't work. That's not true. So let's look at one of these. This is going to be an example of a contradiction. Again, a contradiction is a false statement. So that means it's going to be something that doesn't work. Now, the variables are going to disappear. And we're going to be left with something that's not true. So we begin the way that we always begin. And we begin by distributing through. So we're going to go ahead now and distribute that negative 3 through. I always circle the negatives because you don't want to make a mistake. It's very easy to lose a negative. So we're going to distribute this negative through. So that makes it a minus 3x and a minus 24. And that equals a minus 3x plus 9. Now, how is this one different from all the others? Well, if I try to get the x by itself, like I always do, and I move that x over, that 3x over with addition, like we should do, what's going to happen to the x's? One's positive, one's negative. They're both 3's. They do what? They cancel out. So look at what we're left with now. We're left with minus 24 equals 9. And does minus 24, does that equal 9? No, it doesn't make sense, does it? So this is false. Okay, can't have that, right? Minus 24 does not equal 9, so that's a false statement. So this is called a contradiction. And your solution is going to be either the empty or the null set. Some textbooks use the empty set. Some textbooks just write out null set. No solution. Okay? That just means no solution. No number will ever make it work. So that's our 3 types of equations. Conditional. What does conditional mean? There's a condition. There's a number that works, that solves. So I can solve it and I get a number. If I get an actual numbered answer, like x equals 9 or y equals 12, that's conditional. If, when I work it out, the sides are the same, that's an identity. Infinite number of solutions. If I work it out and the variables disappear and the sides are different like this, the variable's gone, that's clearly a false statement, and that's a contradiction. So those are the 3 types of equations that we're going to encounter. So now we're going to work through some of these here. So I'm going to pick some of the problems from our textbook. Now, 2, 3, and 2, 4 are combined together. We've already done a lot of this, so that's why they're combined together. That was the only new part. So now we're just going to go through. I'm going to pick out some different questions. We're going to learn how to take these and solve them. So we may have to clear out some parentheses. We may have to clear some fractions. But there's going to be no word problems, no applications. These are just solving. When we start 2-5, which will be after we take our test in a couple of weeks, that's where we're going to do the applications. So let's now just look at some questions here. And this is going to combine everything we've learned so far together. I'm on page 124. Let's look at question 34. We've got 9 times 2 minus p equals minus 9p plus 18. So this is nothing really new here. We've done these before. And just combining all the new terms together, seeing what we've got. So what do we do first here? Okay, well, the first thing we need to do is distribute this 9 through. If I distribute the 9 through, then what do I have? I have 18, right, minus 9p equals minus 9p plus 18. Now, are these the same? Yeah, because this can be rewritten as minus 9p plus 18, right, if I switch the order. Okay, and are these the same? Yes. So if these are the same, what is it again? This is an identity. Right? It's an identity because they are the same. And what's our solution set? All real numbers. So this is an identity. Our solution set is all real numbers. All right, let's try another one. Let's try a different one here. How about question 44? I'm trying to pick one of each type, so you'll see what they all are. So question 44. You've got minus, parentheses, 6k minus 5, minus, parentheses, minus 5k plus 8 equals minus 3. And I picked this one because this is one it's very easy, but students tend to make a mistake with this one because of the signs. So first thing we need to do is we need to get rid of all these parentheses. And how do we do that? Distribute. And I always like to circle the negative so I don't lose it. Be very careful with your signs. When you distribute that negative through, those signs are going to switch. So when I distribute the negative through, I get a minus 6k. Negative and negative makes it positive 5. Take your time, be careful with the signs. Negative and negative makes it a positive 5k. Negative and positive makes it a minus 8. Now we can combine. So what do we have? We have a minus 6k, a positive 5k. Those go together, make it a minus k. We've got 5 minus 8, that makes it a minus 3. A lot of times, I know you know how to finish it, but a lot of times what happens is you're going to try to add the 3's together. And we don't. We need to move it over, okay? And they're going to cancel out. So how do we get rid of that negative 3 on the left? It is a negative 3. So to get rid of it, we use a positive 3. That is then going to make it a 0. Now we need to finish it. Can I have a negative in front of that k? No, it has to be the variable by itself. So how do I get rid of that negative? I divide both sides by a negative 1. So that makes it a positive k. And what about 0? Well, 0 divided by any number stays what? 0. So the right-hand side is going to be 0. So now we've got our solution. And what type of equation is it? We got a solution. We got a numbered answer, so this would be conditional. So this is conditional. There's a condition or a number that makes it work. So conditional, just think of a condition, something that makes it work. We distributed through and we solved it. A lot of you may be very familiar with how to solve these. Just be sure and take your time. It's very easy to make a sign error, and then it gets really, really frustrating. So make sure you take your time with these and don't try to rush through them. You can skip steps if you want. I always write them out because it makes it easier for you to see when you go back and look at things, and that way you're also less likely to make a mistake. Let's do one that's an identity, or sorry, a no solution. So let's look at 48. We've already done an identity. We just did a contradiction. Let's do 48, which is going to be a contradiction. So we did identity, conditional. This one will be a contradiction. So again, we begin by distributing through. So we're going to distribute that 6 through on the left and that 4 through on the right. Okay, so let's go ahead and distribute through. We've got 6 times 2x. That makes it a 12x, and 6 times 8, that makes it a 48. So there's that piece. So the left is done. What about the right? We distribute through. 4 times 3 makes it a 12x, and 4 times a negative 4, or sorry, negative 6 there, so 4 times a negative 6, that makes it a negative what? 24. Now I can tell that it's not going to be solvable from here because the variables are the same, right? You've got a 12 on each side, so 12x on each side. So let's go ahead and move that over so we can see that it's a false statement. So solve it just like you always would. But then you get to this point, and here's your conundrum. When you move that 12x over, they cancel. And now we are left with 48 equals negative 24. Well, is that a true statement? No, that's clearly a false statement. So that means this is a contradiction. And you can write down no solution, or you can just use the empty set or the null set. Some textbooks call this symbol the empty set, and some textbooks call it the null set. And that's your answer. It's a contradiction, and there's no number that'll make it work. Now we'll look at some more complicated problems to finish out 2-4. So let's look at some of these. We're going to focus now mostly on fractions because where students struggle the most at is going to be in the fractions. So let's do some more of these that have the fractions in them. And we're going to be clearing these out again, working with them. Let's look now on page 130. Let's look at question 33. We've already done these in the previous section, but we're going to look at them again because now we just have more steps. So this is what we've got. So I want to solve this, and let's really take our time with this one and talk about all the different steps that we're going to be doing. So first off, we have fractions. Now, do we have any parentheses to begin with? No. Okay, if we had parentheses, we would do those first. But this one doesn't have any parentheses. we want to go ahead and get rid of the fractions. You can work with them, but let's just go ahead and get rid of them. And our common denominator that we're going to be using is going to be an 8. Why are we going to be using an 8? Well, would an 8 get rid of all of them? Yeah, because 8 divided by 4 is 2. Okay, so that works. 8 divided by 2 is 4, so that works. And 8 divided by 8 is 1, and it cancels out. So 8 is going to work. 8 is going to clear them all out. What's our procedure? What do? Divide by the number below, multiply by what's on top. Divide, multiply. Divide by the number below, multiply by the number on the top. Once you get used to doing this, it's not difficult at all. And I think this is easier than working with the fractions. So 8 divided by 4. 8 divided by 4 is 2. 2 times the 3 makes it 6x. The next one is negative, so we'll bring that negative down. 8 divided by 2 is 4. So 8 divided by 2 is 4. Times 1 makes it 4x. Gone. 8 divided by 8 is 1. Times a negative makes it a negative 1. And we'll just bring that x down. So that's going to make that a negative x. And then we've got 8 times 12. It's a negative 12. So we've got 8 times 12. We know our sign's going to be positive, or sorry, negative at the end. So that's going to be a negative 96. Make sure you do each piece. Even if it's not a fraction, you just multiply. Divide, multiply, divide, multiply, divide, multiply. There's no fraction, so we just multiply. Now we can go ahead and combine those together on the left. And that's 6x minus 4x. That makes it a 2x. That equals a negative x minus 96. And we need to finish it, so what do? I always start with the variables, moving to the left. So I'm going to add that x over. And that makes it now a 3x, and that equals a negative 96. And how do we get rid of that 3? Last thing we always do is our division. So we're going to divide by 3. And let's see, does 96 evenly divide by 3? I think it does. Yep. And that's going to come out, and that's going to give you, watch your signs here. Negative over positive makes it a negative. And that's going to be a negative 32. And it doesn't ask, but what would this be? Well, this would be conditional. Why is it conditional? Because we were able to solve it, and we were able to get an answer. Now let's try some more fractions. How about question 41? So let's look at question 41 here. 2/3 w plus 4 equals 2/3 times w plus 3 plus 2. Now, before we can clear out these fractions, that's multiplication. So before we clear out our fractions, we have to do our parentheses. So parentheses need to be gone before anything else can be done. We're now going to go ahead and distribute through that 2/3. The left-hand side is going to be the same, because it doesn't change at all. And when we distribute through, okay, 2/3 times w, well, that's 2/3 w. If you struggle with multiplying these fractions, because we can't clear them out yet, we have to do parentheses first. And if you struggle when you multiply through, what do we have? We have 2/3. And that's going to get multiplied by a 3/1. Because that's your 3 there. The 3's cancel. And what are we left now with? 2. So I just distributed it through. Those 3's canceled, right? Because I just wrote it out. If you struggle with fractions, write them out. You can't clear the fractions until you've gotten rid of the parentheses. Parentheses have to be done first. Now, what do you notice? Those can go together, and that's going to make it a 4. And we don't even have to clear out our fractions, do we? Because what do you notice here? They're the same, right? Okay? So we don't have to clear out the fractions. You could, but why do all that extra work when you know these are the same? This is an identity. So these are the same, so this is going to be an identity. And your solution set, again, is all real numbers. I want to do one more fractional question, and then we'll look at some decimals, just to make sure we know how these decimals work. So one more fraction one, and then we'll do a couple of decimal questions, and then that's going to finish up our homework. So that was 41. Let's do one that's got more fractions where you have to distribute through first. Let's look at 51. So question 51, we've got 2/3 k minus parentheses k minus 1/2 equals 1/6 times k minus 51. So this is what we've got. So let's go ahead and get rid of our parentheses first. So that's what we always do first, is the parentheses. So we're going to go ahead and distribute that negative through. Now, that doesn't really do anything but change your signs. And then on the right-hand side, we've got to distribute that 1/6 through. Distributing through, we get 2/3 k. We've got a minus k. And negative makes it a positive 1/2. On the other side, we've got 1/6 k. And what about here? Well, we can reduce it down if we want, but let's just leave it as it is. So we have 1/6 times negative 51. So that's going to be a minus 51 over 6. Now you could reduce that down to 17 over 3, but it doesn't matter because we're going to get rid of it. Okay? You can reduce fractions down if you really want to. Not going to matter because we're going to get rid of it. Because that's a 51 over 1, so nothing to clear out there. How do we get rid of our fractions? Well, that looks like we need a least common denominator. And we've got a 2, a 3, and a 6. So to get rid of all the fractions, I'm going to multiply everything by what? Can someone tell me? What would I multiply everything by? Multiply it all by a 6. Yep, very good. Just want to make sure we see what to do here. So multiply everything by a 6. Take your time. And what's our procedure? Divide, multiply. Divide, multiply. So, 6 divided by 3, 2. Times 2 makes it 4k. Negative will come down. So 6 times a negative k, well, that just makes it a minus 6k. Next, 6 divided by 2, 3 times 1 makes it a 3. Next, 6 divided by 6 is 1 times that k makes it k. 6 and 6 cancel. That leaves you then with a negative 51. Very simple once the fractions are gone. Now we need to clean it up. So before you start moving things around, always clean it up first. So these can go together. And that's going to be a minus 2k plus 3 equals k minus 51. Be very, very careful with your signs. This k needs to move over, so it's going to be a negative k. Minus 2 minus 1 makes it a minus 3k. Plus 3 equals your negative 51. Next step, move that 3 over with subtraction. Now we've got a minus 3k equals a negative 54. And we're almost done here. So we need to divide by that 3, that negative 3. So divide both sides by a negative 3. And what do we know about a negative divided by a negative? Negative divided by negative is positive. If you use your calculator, 54 divided by 3 makes it 18. So negative over negative makes it positive. So that would be k equals 18. And this again is conditional. Let's do a couple of decimal ones, and that'll be it for today. So let's look at a decimal one. How about we look at 73? That's 0.3 times z minus 25 plus 0.6 times z plus 15, and that equals a negative 12. Some instructors might have you clear the decimals. I think that is more confusing than just using a calculator, and I think you're more likely to make a mistake. So we're just going to use our calculator here for all these decimals. You could clear them all out by multiplying everything by 10, but you're likely to make a mistake when you do that. It just adds in an extra level, I think, of difficulty to the problem. We've got calculators. We're going to use our calculator. So we're going to distribute through, and we're going to use our calculator when we have to multiply these decimals and divide them. So don't clear them out. Some instructors might have you clear them out. I think that is just asking for more problems, and you're more likely to make a mistake. The more steps you do, the more likely you are to make a mistake. So we're going to use our calculator. That's what we've got them for. So when we distribute through, we've got a 0.3 times z. So that's 0.3z. And we know our sign's going to be negative, so I'm going to use my calculator here. Let me brighten this up so we can hopefully see the calculator a little bit better. Okay, so this is what we've got. We're going to go ahead and multiply through. We know our sign's going to be negative, so we've got 0.3. Multiply that by 25. That's going to give us then our 7.5. We took care of our sign, so we didn't have to put that negative in the calculator. Next, we've got a 0.6z. And then we've got a positive and a positive, so that's going to be a positive. And what do we have here? Well, we've got 0.6. Multiply that by 15. And that comes out to be the whole number 9. And that equals a minus 12. Now we can go ahead and combine. Use your calculator if you need to. Or you can do these mentally. It doesn't matter. Z's, we'll do the variables first. So 0.3, 0.6, add them together. 0.9z. Next, we've got negative 7.5 and positive 9. 9's bigger, sign's positive. So now we'll just go ahead and subtract. So what do we have? We have 9 minus 7.5. That comes out to be 1.5. And that equals now your negative 12. We're going to go ahead and finish this out by moving things over. Just be careful with these decimals. So we're going to move that 1.5 over. Always be very, very careful with the decimals. We know these are negative, so my sign stays negative here. And what do we have? We have a 12 and a 1.5. Those go together to make it a 13.5. And that equals a 0.9z. And just like with whole numbers, get rid of it. Divide by 0.9. And that is then going to leave me with z equaling now. Let's see what we've got. Okay, we know our sign's going to be negative, right? Because negative over positive makes it negative. So 13.5. Divide that by 0.9. That becomes a 15. We know our sign's negative. So what's my final answer going to be? Negative 15. So z equals a negative 15. And this is conditional. Yeah, we might as well just do one more quick one here. That was 73. Let's go back and let's do another one that's an identity. How about we look at 71? So this will be the last one that we're going to look at. And then we'll talk about our homework. So 71. We have a 2.4 x minus 1.4 equals 0.8 times 3x minus 2 plus 0.2. So we're going to go ahead and work with this one. Again, use a calculator for these decimals. Do not try to clear them out. Some instructors have you clear them out. I think that's just asking for trouble. We've got calculators, we might as well use them. The left-hand side is already done, so that's 2.4x minus 1.4. The right-hand side, when we distribute through, we're going to go ahead now and take that, this up here, we're going to go ahead and take that 0.8 times that 3. Now that's going to be, again, a 2.4. So notice how these are already the same. So it looks like it's either going to be a contradiction or an identity. We'll do the next one the same way. 0.8 times a negative 2. Always put the positive in. We know our sign's going to be a negative. So that's a minus 1.6. And now what's going to happen when we put these together? That gives you a minus 1.4 together with that 2.4x. And what about the left-hand side? Well, it's the same. So these are the same. So this again is an identity. And what's your solution? All real numbers. So let's talk about what we've got going on next week. And as everyone knows, next week is going to be our first exam. So let's talk about what we can have on that exam next week. So our exam is next week. Now your exam is going to look very, very similar to that practice one. So if you do the practice exam and understand how to do those, you'll be fine on your exam next week. So that exam next week, what can you have? Well, you can have either a page of notes, front and back, or you can have note cards. If you'd rather have problems put out on note cards, you can do that. You can bring in as many as you think you need. Maybe you want 10 or 15. But if you want to use note cards, you can bring in as many as you think that you need. If you want to write out examples and what they are on each one, the note cards, you can do that. So you need a page of notes or note cards. You'll need to bring in your own calculator. I'll bring some in, but it's better if you have your own. So you need to bring a calculator and scratch paper also. Now what else is going to happen next week is I'm going to collect that homework. So what's due next week is your homework packet for Chapter 1. So that entire packet is going to be due next week. So make sure you have that whole packet finished for Chapter 1. Also, what else do we look at? Not going to be collected, but what else do we talk about today? What's your homework? Well, your homework is review for that exam and do 2.1. You should be able to do them all. 2.2. You should be able to do them all. And then 2.3 and 2.4. You should be able to do them all. They're combined together. And there's not that many. It shouldn't take you that long to go through them. So that's going to be your homework, is to do 2.1 through 2.4. You should be able to do them all. No applications, no word problems in Chapter 2 so far. So they're just going to be solving out equations. So that's what we're going to be having next week. Next week is our first exam. And make sure your homework packet is finished as well. Make sure you work on that practice exam because you'll get 5 points for just working it out. I'll have the notes posted online for you after class, as well as a worked out copy of that practice exam. So we'll see everyone then next week, and hope that you have a great rest of your day.